Before we start looking at what a vector is, I need to introduce a word that you're probably familiar with, and the word is scalars, of course. Scalars have been probably introduced in some earlier courses, and we're going to be using them quite a bit in this linear algebra course. So what is a scalar? Well, a scalar can be any whole number, 1, 2, 3, 4, 5, or it could be a negative number, -3, -7, -12, or negative whatever you want, or even 0, right? It could be a fraction, positive or negative. It could be a root, or any kind of root, not just a square root, or it can even be any one of those strange transcendental numbers like e pi, ln 5, etc. So in other words, a scalar is simply a real number. Okay, so why do we call it a scalar instead of calling it a real number? Well, for one thing, scalar is shorter than real number, but also one of the features of linear algebra is that of using very specific, very appropriate jargon in any situation. And in some situation, we may want to identify a scalar as a real number with other properties as well. In fact, later on, once we become familiar with this use of scalars, we're going to see other kinds of scalars, or you are going to see them because we're not going to look at them in this particular course, but you're going to be seeing some situation whereby scalars will mean other things that act like real numbers but not quite real numbers. Okay, so this is something which is peculiar of linear algebra, even though you may have heard the word before. And in fact, one peculiar thing about linear algebra in general is the fact that it uses both new words, words that you'll have to get used to, that you may not have heard of before, and whose meaning and conceptual content you want to understand, as well as old words with new meaning, like scalars. Again, we're going to start by using scalars in the meaning that is more common, but later on you might extend that meaning to something else. Right, so now that we have clarified what a scalar is, let's see what a vector is. We're going to start with the simplest kind of vectors, namely two-dimensional vectors, or simply 2D vectors. So what is a 2D vector? Well, as its name implies or suggests, a 2D vector is simply an ordered pair of scalars. Okay, so what do I mean by an ordered pair of scalars? Well, it's two scalars, let's call them A and B, but they are in order, which means that if I consider the set the pair AB, it's not going to be the same thing as the pair B comma A. So it's simply, we think of it as just two numbers. First we have to identify the first one, then the second. Okay? There are alternative notations, and this is another peculiar characteristic of linear algebra. We're going to learn and get acquainted with a whole bunch of new notations, and you want to get used to them. Another characteristic of it is sometimes in linear algebra the same objects are described by different kinds of notations. I'm going to stick as much as possible to one of them, but don't be surprised if you see the other ones in other courses or in other textbooks or something like this. So what are the alternative notations? I'm going to start first of all with the one that I'll be using, and that is by putting the two numbers A and B in order, first A then B, within square brackets with no comma in between. Why is that? Well, the no comma is just simplicity. We'll avoid writing things if we don't need to, but it's also to keep it in tune and in synchrony with another kind of notation we're going to use later, namely that of matrices. But there are other notations that people use, and you will find again in textbooks, articles, and so on. For instance, people just use the same notation but with a comma in between. That's fine with me. If you want to spend extra ink or use extra ink or extra lead, that's fine, but I'm not going to bother with that one, except when omitting the comma will create confusion about where one number starts and the other one begins. Another one which is quite common, in fact your official textbook may use that one, is the one which uses round brackets. I'm not going to use that one because it is easy to confuse a vector written in this way with the coordinates of a point, right? We've used that notation to describe the point of coordinates AB. Well, there is some connection between the vector AB and the point of coordinates AB, and we're going to see that soon, but they're not quite the same thing, so I'm going to avoid that one. Another notation you'll find is the one with these strange angular brackets. Again, I'm going to reserve that notation for a different kind of object, so I'm not going to use it, but don't be surprised if you're going to see that one used somewhere else. Sometimes people want to refer to vectors simply as objects, and we don't really need to specify it's the numbers that make up what the vector is. So in that case, we may want to use just a single letter. So when we do that, oh, right, I forgot about it. Hey, thank you for reminding me, Mr. PowerPoint. There is another notation that we're going to see soon, and that is notation where the numbers that make up the vector are written not horizontally but vertically, still with square brackets but written vertically, the first number on top and the other one on the bottom. So keep that one in mind, because that actually is going to be used fairly often. Now, as I was saying, if we want to use a single letter, a shorter symbol to represent a vector, the usual notation is simply to use a bold lowercase letter. So V, of course, for vector. So V, bold case V, would be the vector AB. So one number, then another number. There are other notations similar to this one that you probably have seen before, namely the bold lowercase letter with a bar on top or with an arrow on top, sometimes with a bar on the bottom, and so on. These are complications that, unless are needed in order to really clarify what we're talking about, I'm not going to use. Okay, feel free to use them though. I mean, as far as you are concerned, I will accept any one of these notations as long as they do not create confusion. Okay. Now, so this is what a vector is, but as you can notice, this is pretty blah, pretty abstract, right? Okay, it's two numbers, first one, then the other, duh. Okay, so what are we going to use with it? Well, as I've already mentioned, these vectors are interpreted in many ways. For 2D vectors, you're probably very familiar with the interpretation of a vector as a directed segment, or an arrow if you want. And this is used then in turn to represent things like the position of an object, the velocity of an object, the acceleration acting on an object, or the related force, and so on and so on and so on. So there are all these interpretations that we're going to see as we move on through the course.